The issue in the knowledge-based recombinant system is when we have the requirement and the requirement is unsatisfied. So the users give all the requirements, but no result or no solution could be found. And in this case, we need to do something. For example, we need to relax the constraint, or we call it the constraint relaxation. The goal is to identify relaxation to the original set of constraints. So we have the constraint, and then we need to change or we need to revise the constraint. Relax constraint of a recombination problem until a corresponding solution has been found. So it means at least maybe one product can be found, at least one product can be listed to the customer. So in this case, user could also be interested in repair proposals. So repair proposal means the user requirement should be changed, or we, the store, should have another kind of proposal. Recommender can calculate a solution by adapting the proposed requirement. So if the proposal has been repaired, then we can have another solution. Or the other kind of things is ranking the items. So if there is no solution, then we just rank the highest or the nearest to the requirement is this is number 1, this is number 2, this is number 3, for example. There are some ways to deal with unsatisfied requirements. So in this method, we can calculate the diagnosis. Diagnosis means D. So we can calculate the diagnosis for unsatisfied requirements. So a diagnosis is a minimal set of elements. Elements means R1, R2 until Rk, and it will be in the D or in the diagnosis. That is a subset of REC. REC means the requirement. It is the set of elements that have to be repaired in order to restore consistency with the given product assortment. So at least one solution can be found. So what does it mean by this one? So the idea is this one. If we have the requirement minus the diagnosis, it should not be, this is not equal. Okay. So the top of the requirement minus D of P should not be empty. This is empty. I miss the one. I miss the stones. Should not be empty means there should be at least one solution. If the solution is empty, then it is still unsatisfied. So at least one solution can be found. We need to define the conflict set. So what is conflict set? So based on the research by Junker in 2004, it is defined as the subset R R1, R2 until RL of the requirement such that the constraint or the conflict set of a product give you empty solution. So CS is the conflict set. Let's say I have the requirement. Okay. The requirement is R1, price is less than 150. R2, the optical zoom is 5 times. R3, the sound is yes. R4, the waterproof is yes. Okay. Now, among all those requirements, I need to check which are the conflict set. The conflict set means the combination of the requirements such that we have no solution. So we need to look at the unsatisfied requirement by combining the R. So we have this rec or the requirements, and this is the data. Now we will look at the corresponding conflict set. Okay, so we have the R1, R2, R3, R4. First, we will check, let's say, this conflict set 1. Let's look at the R1 and R2. I want to know whether I can give recommendation where the price is less than 150 and the optical zoom is 5 times. Okay, I need to look at the optical zoom 5 times. And the price is less than 150. The price is 182. Then we don't have the solution. So we call this is the conflict set. R1 and R2 is conflict set because there is no solution. And then let's check. Suppose I want to remove the R1. So I remove the R1 and I want to check if I have the R2. Now I can combine with another requirement. For example, in this case, I want to check with R4. So R2 and R4. If the optical zoom is 5 times and I want to check whether it is waterproof or not. So optical zoom is 5 times and waterproof is no. Okay, then again, this is another conflict set because there is no solution. Then from this one, we can take a look more. For example, if I include or exclude R2, if I exclude or include R2, and so on. From this one, from the first, we can also consider another solution because I know that R1 and R2 can produce empty solution. Then let's try to remove R2. Now I have R1 and R3. So R1 is price is less than 150 and the sound is yes. So the sound is yes, sound is yes, sound yes, 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 yes. But are there any product which is less than 150? This is no. This is no. This is 151. No. This is no. This is no. And this is no. Then no solution. Then this is another conflict set. So you can do with other thing. Let's say if I want to look at the R2 and R3, R2 is the optical zoom is 5 times and the sound is yes. Okay, then it is good. Then this has solution. In this case, the corresponding conflict set, yeah, we can have the combination of R1 and R2, R2 and R4, R1 and R3. So this is the corresponding conflict set, R1 and R2, R2 and R4, and R1 and R3. This is the conflict set because when we combine those two requirements, it produces empty. It produces empty. It produces empty. So we want to remove the requirements so that we can have at least one solution. So in this case, we can have the idea that the diagnosis or D derived from the conflict set CS1, CS2, CS3. So the D is R1, R2, R1, R4, and R2, R2. This one. At moment. Okay, I will fix this one for the PowerPoint. I will submit again to the class. There's another way to deal with the unsatisfied requirement. We call it the minimum relaxed algorithm. The minimum relaxed algorithm is used to determine the complete set of minimal diagnoses. What does it mean by minimal diagnosis? So we want to minimum the diagnosis that cannot give any solution. So for example, here we have 3. Okay. So we want to reduce the minimum set that cannot give any solution. So let's say we have this data again, and we can make a binary. Yes, no, true, false. In this case, the R1, and we want to look with the P1, P2, P3, P4, P5, P6, P7, and P8. So in the R1, it shows that, okay, we have at least one solution. Okay, this is one solution, and the other does not apply to this requirement. R2. For R2, we also have only one solution. The other product does not apply with the requirement. R3. We have 1, 2, 3, 4, 5, 6. For R4, we have 1, 2, 3. Now we can see the relationship easily. So it depicts the relationship between the example of requirement and each of the product. Each column of the table represents a diagnosis. So the goal is to identify the diagnoses that are minimal. Then, yeah, we can just look at this one by looking at the complete set of minimal diagnoses. So if you see this one, okay, the R1 and the R4, okay, it can work, okay, and then R2 and R3, it can work together, and then the other is R3 and R4. So yeah, we can use this minimum set of diagnosis to look at the solution. We can also do the repair. So as I mentioned to you, we can repair the unsatisfied requirements. Repair means revision. We can make changes to the unsatisfied requirements. We can identify the possible adaptation. Possible adaptation means if I have the diagnosis R1, R2, R1, R4, and R2, R3, then we uh, we will try to adopt some possible adaptation. Okay. Let's say, okay, we can deal with only R1 and then we can deal with only R2 and what we already looked at this one. So the query can be used for this one. Query the product table P with the attributes of D with the requirement minus the diagnosis. So for example, we have the attribute D1, okay, and then we want to change the requirement according to the D1. The price set 150 and then the optical zoom has been set 5 times. So we repairs this one. The price is higher and the optical zoom becomes higher. So it means we change the value so that we can find a solution. We also can do this one with the D2, R1, R4. So the D2 means the R1, the price. We increase the price and the waterproof change. If we have this D, for example, the D3 is R2 and R3, then the R2 is optical zoom. Let's say we downgrade the optical zoom and the sound becomes no. So we revise or repair the proposal. And we can get like this kind of repair proposal. So this repair proposal, again, we will check if the requirement is this one, then what is the result of the diagnosis? If we have this requirement, what is the diagnosis? If we have this requirement, what is the diagnosis? So we can do again for finding the conflict set and etc. For ranking the items, then we will use the utility theory. The utility theory means I want to check what is the value, or we want to see the predefined set of dimension that provides an aggregated view on the basic item properties. Let's say I want to buy a digital camera. Okay. So in the digital camera, we have the knowledge that quality and economy are the dimension. So we have the rating score for the quality and the economy from 1 until 10. We define, let's say the price, if the price is less than or equal to 250, so the quality is 5 and the economy is 10. Okay, so it is a kind of trade-off. Higher Price means it is maybe related to high quality, but the economy is low. If it is low price, the quality may be low, but the economic is high. So it is a trade-off between quality and economy. So the most difficult part is how to define the value of this rating. For example, MPix, the megapixel. The megapixel, if it is lower than 8, so I can make a rating. The quality is 4. And the economy is 10. But if it is higher than 8, the quality is good. But the economy is maybe about 6. How about the optical zoom? If optical zoom is high, oh, of course, this is very good. Okay. People will give a high rating. But from the economic perspective, it is not good. If the optical zoom is less than 9, okay, the quality is not that good, and the economy maybe not maximum. Okay, so this kind of rating you can generate. After you have this rating, you can do the calculation. For example, what is the customer specific interest? The customer one, the customer one think that I want to have more quality than the economic. I don't care about the price, but I still have some maximum price. Then the quality is more, or maybe 80%, and the economic is 20%. For the customer two, the quality is 40% from the rating, and the economic is 60%. Then we can calculate the utility. Okay. How can we calculate the utility? For the customer one, this is the utility calculation. For customer two, this is the utility calculation. So how can we calculate this one? For the product one, this one. I use this product. Okay. Okay, for the product one, we need to check what is the quality and what is the economy. The product one, the price is less than 250. Then product one, quality is 5. What about the megapixel? The megapixel is 8. Okay, because it is 8, exactly the same 8, then the quality is 4. We have 4. What about the optical zoom? The optical zoom is 4 times. Because it is less than 9, then the quality is 6. What about the LCD size? The LCD size is 2.5. Okay, less than 2.7, the quality is 6, and so on. So we can do the summation. The summation is 41 for the reading. What about the economy? Yeah, the same. For the economy perspective, the price is less than 250. Okay, the rating is good. 10. So we have 10. For the megapixel, it is higher than equal than 8 or higher than 8. So in this case, it is equal to 8. So the economic is 10. So we have 10. And so on. So for every product, we have the calculation, then we will do the summation. And after we have this, we have 41 and 65. Then how can we get the CU1? The C1 means we need to check the requirement from the user. In this case, the user or the customer one, they specify the quality is 80% and the economic is 20%. And the quality, it means 41 multiplied by 0.8 plus 65 multiplied by 0.2, and it equals to 45.8. After we have this number, okay, so you can calculate for P2, you can calculate for P3, you can calculate for P4 until you have the calculation for P8. After you have those numbers, then what will you do? Is to do the ranking, the rank. The higher values is the better, because as we know from this one, if the ranking is high, then it is good. Then this is ranking number 1. Okay, for the customer 1, we can give the P8, P7, which is the ranking 2, and P6, which is the ranking 3. So we can give 3 products recommender to the customer 1. For the customer 2, we have the P2, P3, and P5 for the customer 2. Okay. So we can give this item based on the product knowledge and the rating, and we rank based on the utility. There's another method, we call it case-based recommender system. So the case-based recommender system, we are going to look at the items that are retrieved using similarity methods. So we will have the distance similarity. The distance similarity is using this one, similarity P, comma, requirement. P is the product, and then based on what is the requirement. Here is the formula. It is the summation of weight, or WR is the importance weight for requirement R, or yeah, weight, and the similarity of the product with the requirement. Sim PR means this is for each item attribute value. P, it's distance to the customer requirement, R. So in the real world, customer would like to maximize certain properties. So it means, for example, the resolution of a camera. More is better. Of course, if we can get a good camera, we are happy. The high resolution is better. But we want to minimize certain properties. Price of a camera. Less is better. Yeah, this is human being. We want to have a very good quality with less price. That's common. Then using this one, we can calculate the similarity. The similarity is based on the certain properties. First, we can maximize the properties. To maximize certain properties, for example, the resolution of camera, we can calculate more is better. more is better. It means I want to check the similarity from the product minus the requirement. Or sometimes we can also make in the opposite. We want to check the requirement based on the some options in the product. Minimize certain properties. For example, price of a camera. So I have less is better. So this is the formula. I think if you know about the normalization, okay, so the idea of this formula is similar with the normalization, but we are looking at the similarity. So there are situations in which the similarity should be solely on distance to the originally defined requirement. And in this case, yeah, we have the similarity. It is 1 minus by, we have an absolute because sum of the product minus by the requirement, it will be divided by the maximum and the minimum of the requirement. So let's say we have one example. We have this database. Now for this similarity measurement, let's make like the opposite. As you know, the price is less is better. And the megapixel or the resolution maximum or more is better. So we have the requirement. The requirement is the price is 150 and the megapixel is 8. Then suppose price is using LIB and MPix use MIB. And based on this database, so let's take a look. The maximum price is 278. So this is the maximum price. And the minimum price is 148. And the max pixel is 10. And the minimum pixel is 7. Okay. Then from this data, we can calculate the similarity of the requirement from the user with the database that we have. So we can calculate. For the price, this is the similarity 0.98. And for the, this is the similarity. In order to check the overall similarity, because we have the price and the megapixel. So let's assume, okay, that the weight is 1 for every of the attribute. Because the weight is 1, then 1 multiplied by the similarity of price, which is 0.9846, plus the similarity of the megapixel, MPix, divided by 2, divided by the weight. Then, okay, we have the overall similarity is 0.6475. Okay. Now, what does it mean by this similarity? It means that the user requirement is about 0.6475 with regard to this database. So let's say in this database, it is the store. So when I visit the store, okay, my requirement is similar, about similar like this one. So let's say, okay, let's say you visit in one store and you have those numbers. Now you visit another store and then you want to have the same requirement. And then to check. Okay. What is not required with the index store. So with the same requirement, price is 1 and megapixel is 8. Suppose there is another store, let's say store 2. So price using the LIB and MPix use MIB. Let's say the price maximum, okay, is now changed 288. And the minimum is 148. And okay, in this store, they sell more high level product. The megapixel is 15 and the minimum is 4.1. So again, we can calculate with the price, which is less is better. And then the megapixel, which is MIB, more is better. And using the same width equals to 1, we can calculate the overall similarity. So the similarity like this. This is plus. This is plus. Okay, so plus, it means the user from the is your white 7,000. Then we can have a comparison. The star one has the similarity with the user requirement as much as 0.64. The star 2 has the similarity score as much as 0.67. And we know for the similarity value means higher is the better. Or if it is near to 1, then it is good. So star 2 has more similarity score than star 1. And the product in store 2 has more similarity to the requirement than store 1. So for the case-based recommender, there will be some kind of interaction. What does it mean by interaction? First, the same with the constraint base. Customers maybe not know what they are seeking. So they do not know what they want to look for. That's why they will do critic. Critic means it is to support the navigation. Customer can specify their change requests, for example, price or MPICs, that are not satisfied by the current item or the entry items. So here is the price and this is the MPICs. So we can make a kind of coordinate. If the price is high, if the price is high, then it goes to the right. Now we want to check the optimum solution. If it is more expensive, it goes up. If it is cheaper, it goes down. If it is more pixel, it goes to the right. If it is less pixel, it goes to the left. Now, what is the product that is the most similar to the user requirement? Let's say the entry item is here, the white one. And the most similar item in this case. Okay. Then we can recommend this one, which is the most similar. Or sometimes we can also do with thresholding. Okay, we can have the thresholding. In this case, we can say we want to critique on the price. So on the price, we set this one, and the entry item is here. Because this is the entry item, then let's look at the user requirement. If the user requirement say that, okay, I want to have the product which is higher than this price. So all those products can be the recommended items. Or I want to have products which is cheaper than this entry item. Then it means I can recommend the products that is cheaper from this one. So we can use this interaction, or we can use this kind of visualization. So in the critic, we have single critic, we have compound critic, and we have dynamic critic. Okay, let me stop here. So let's have a break. I will continue after the break.